Welcome to a final video in this course, albeit a very important one. Today we're looking at testing, and hopefully it'll be quite a short video too to finish off, but like I say, very important. So we're going to look at two types of error mainly. There's a couple of main types of error, but you only need to know two of them. First of which is syntax error, and you may have come across the syntax. The definition of syntax is the grammatical rules of a programming language. So different programming languages do the same job in a different way. They use different words, different statements. So for example here, and often you have something called syntax highlighting. We talked about the IDE a couple of videos ago, and some IDEs in the text editors highlight different types of syntax. So there's sort of different rules. You get used to it as you learn the programming language. You're really learning the syntax. And what happens when you break the syntax is you get a syntax error. So this is where one of these rules, so for example this is equal to, you do a colon, you do indent, that's part of the syntax of Python, and a syntax error is when one of these rules have not been obeyed, and it's very common, especially when you're learning, and even when you're experienced, they happen quite a lot. So just so you know, occasionally a syntax error won't be called it straight away, and part of the software in the IDE is that it shows you errors often, and this doesn't actually say it's a syntax error. This next example does, but here it's just saying a bit more information about the error, but it is technically a syntax error. It's just isn't sure about that, but this is definitely a syntax error. You should have a colon here, but it doesn't, so we get a syntax error when we try and run it. Then you have something called a logic error, and a logic error is slightly different, and it's actually a lot harder to detect, because really they occur when the code runs as normal. So you run your program, it runs as you would hope without error, but you realise that there is something wrong with it. It runs, but not as the programmer intended. So this may mean that the function of it doesn't do what you want it to do, even though you expected it to. The code, a bit of your code works, but not as you expected. And this is just an example. I remember very vividly me doing my controlled assessment in the past, and I got stuck on this because I was trying to loop something like this. So this code is meant to print the numbers 1 through to 99, but there's a break here, and the code runs, but it just prints 1. It doesn't print every number. If it was right, we'd get a whole list of numbers. It doesn't happen because I've put break here by mistake, and so we get a logic error. Although it runs, but not like this where it's quite well defined. It's something you have to look back on and try and fix yourself. Okay, finally for this video we're going to look at different types of test data. So this will come into your exam, it will come into your controlled assessments. They like these sort of questions in the exam, and testing is obviously done to find and eradicate these errors before the program's used by people. And when testing, certain test data should be used. So when you're really talking about an input, especially with like a function where you're I don't know, I'm using an example in a sec of multiplying. If anything's being inputted by the user, you need to test it using certain test data. So you need to sort of artificially put data into your program to test what the program does with it. So first of all, you want to put the data you actually expect to be inputted normally. So this is just the stuff that normally would be input. So for a multiplication program, you'd put numbers in that you'd expect the actual person using it to put in, just to check that the actual function works. Then you'd put in a data that's unexpected, data that's unlikely to be inputted normally, such as massive numbers, minus numbers, etc. Then you'd put in invalid data. So this is data that's deliberately wrong, almost like you're trying to break the program. You're trying to test for robustness in this case, how the program deals with errors. And an example of this is if you're looking for integers and you type in a string instead to test how the program responds. Often you'll have some sort of error catching in place where you try and stop errors occurring before they do, such as a loop that means until you type in what the expected data, it won't let you actually do anything, which just stops it crashing basically. So, an example, a common way to put it in a table, and what the exam would say in the specification, they want you to know about expected outcomes, and this just means that in every test you should always write before you test what you expect, and therefore you can compare it to the actual outcome. This is especially useful when you're testing for logic errors, when you use a trace table, which is slightly different to this, but what this is showing, so this is like just a multiplication thing, and it's showing these three types of data that I talked about. There's also null. Null is where nothing is put in, which is sort of slightly different. It's sort of like invalid data where nothing's put in, and often you get something called a runtime error, which is also another major error, but you don't need to know about it in your course. So yeah, just syntax and logic errors and test data for this video. So nice and quick to end it off. Hopefully this series of videos have been useful. Well done if you got this far, and yeah, good luck in your exams.